Hi students, problem number 8. Two whistles A and B have frequencies 660 Hz and 590 Hz respectively. An observer is standing in the middle of the line joining the two sources. Source B and the observer are moving towards the right with velocity 30 meters per second, and A is standing to the left side. If the velocity of sound in air is 300 meters per second, find the number of beats heard per second listened by the observer. Okay, now let us take this is a line along which two sources of whistle. See here, this is the source A and here is the source B. Exactly at the midpoint is the observer. So O is the observer. Now the frequencies of A and B. Let us take the actual frequency of A is 660 Hertz and the actual frequency of B is FB, so that is equal to 590 Hertz. Now this A is standing at the left, it is at rest. So the velocity V A is equal to 0. Now B and the observer both are moving towards the right. So they are moving towards the right. I will take this is the right side along the positive x direction. So what is the velocity of the observer as well as the other source is 30. So this is a 30. So velocity of B, this is velocity of observer, both are equal. So this is equal to VO equal to VB and that is equal to 30 meters per second. Okay. If the velocity of sound in air, so the velocity of sound in air is taken as V is equal to 300 meters per second. So all the given quantities I have noted. Find the number of beats heard per second as listened by the observer. It is a different type of problem in Doppler effect, but very easy and interesting. So, my dear students, you have to remember that along this straight line, two sources are at A and B, and O is the midpoint where the observer is standing initially. Now, after some time, the observer as well as the source B both are moving towards the right. But since they have the same velocity 30 meters per second, there is no relative motion between O and B. Is it not? So, no relative motion between the observer and the source B. There is no relative motion. Therefore, what frequency will be listened by the observer is exactly equal to the actual frequency of B. So, I will write there is no relative motion between the observer and the source B. Therefore, the apparent frequency FB dash listened by the observer, okay, due to B is equal to its actual frequency. Are you understanding this concept? When the observer is going behind the source B with the same speed as that of the source B, whatever frequency emitted by the source B will be listened by the observer. There is no change in the frequency. Therefore, the apparent frequency of the source B as listened by the observer is equal to its actual frequency itself. Is it not? So, what is the actual frequency of B is 590 Hz. So, this must be equal to what? 590 Hz. But in this case, when the observer is moving along the positive x direction, he recedes away from A or not? He is moving away from A, receding. Therefore, the frequency listened by the observer due to A will not be the same as that of FA. some other frequency. Therefore, f dash a, this is equal to the actual frequency of a multiplied by v plus v medium minus v observer divided by v plus v medium minus v source. So here the source is A, is it not? It is at rest. So V source is 0 and medium also is 0. But now the observer is moving along the positive x direction with the velocity VO. Therefore, this F dash A must be equal to FA. The actual frequency of A is what? 660. So this is 660 multiplied by V minus VO. So what is the velocity of sound given as 300? So V is 300. So this is 300 minus V observer is 30 divided by the velocity of sound is 300. So that this is now equal to 660 multiplied by 300 minus 30 is 270 divided by 300. So now this 0 and 0 get cancelled first. This 0 and this 0 also is getting cancelled. 27 by 3 is 9. Okay. So this is 66 multiplied by 9. So I will find it out using a calculator. What is 66 into 9? That is found to be 594. So 594 hertz. So what is this frequency? Is the apparent frequency listened by the observer due to the source A, and the apparent frequency observed due to the source B is its original frequency only. Is it not? That is 590. So the difference between these two frequencies only will be equal to the number of beats, isn't it? Therefore, the number of beats heard per second, okay, number of beats heard must be equal to the difference in frequency, that is 594 minus 590, and that is equal to 4 hertz, 4 beats per second. That is the bit frequency I have written. So number of beats means 4 per second. That is also the bit frequency, that is called as what? 4 hertz. So this type of problem are very commonly asked in the multiple choice question in our own board exam itself. I hope you must have understood well. Fine.